All right, let's talk about your Week 6 Java assignment. If you're looking at all the requirements and it feels like a bit of a mountain, don't worry, you're in the right place. We're going to break this whole thing down into a clear, manageable mission. By the time we're done here, you'll have a rock-solid plan all centered around two key concepts in Java: file I/O and handling exceptions.
Okay, so here's our game plan. First, we'll nail down the mission itself. Then, we'll design the blueprint, which is our student class. After that, we dive into the real action, writing and reading data. We'll also cover how to handle the unexpected with some error handling. And finally, we'll go through a little checklist to make sure you snag every single point.
So what is the big picture here? Well, your mission is to build a small but totally functional student record system. Think about what that means. You're going to capture what a user types in, you're going to create these little student objects in memory, and then, and this is the most important part, you're going to save that data to a file so it actually sticks around. Now this right here, this chart tells you the whole story. Just look at that huge purple slice for file I/O and update. That's 140 points. That is almost half your grade. This tells you that the real heart of this assignment is making data persistent, managing how it flows in and out of your program.
And it all adds up to this big number, 300. But don't think of it as one giant task. It's more like a collection of smaller puzzles. Every little piece we talk about, from a perfectly formatted toString method to a solid try/catch block, is just another step toward getting all 300 of those points. So where do we even begin? Well, before you can manage any data, you need a place to put it, right? You need a container. And that's exactly what the student class is. It is the absolute foundation of this whole project. It's the blueprint for every single student record you're going to create.
And your blueprint needs to have these 5 specific fields. Every single student object you make is going to hold a first name, a last name, an ID, a major, and a GPA. Seriously, getting this class structure right from the get-go makes everything else that follows so much easier. And this slide, this shows you exactly why that toString method is worth a whole 25 points. On the left, you've got what a computer likes to read, just raw, comma-separated data. But on the right, you have what a person can actually read: clean, labeled, easy-to-understand info. This method is all about making your data readable. All right, our blueprint is ready, so now we get to the action. This part is all about the output in I/O. We're talking about asking the user for information, turning that into student objects, and then actually writing them to our text file.
The process here is really just a loop you're going to run 10 times. Step 1, ask the user for the info. Step 2, use that info to create a new student object. Step 3, stick that object into your array. Once that array is full, you'll write the whole thing out to the file and make sure you put that required header line in first.
Now, hold on, because here's a super important technical detail. The rubric is very, very specific about this. You have to use character streams. Think file writer or print writer. Why? Well, because you're working with text, right? Letters and numbers, not some raw binary code. This isn't just a friendly suggestion. It's a hard requirement to get full credit. Okay, this next part is where your program really proves itself. See, it's not enough to just write data out. You have to prove you can read it back in, change something, and then save it again. This is what I call the round-trip test. And trust me, it's a huge chunk of your grade. So, the cycle starts with what we've already covered. Your program has gathered up all that input from the user and has written 10 student records to your studentinfo.txt file. At this point, that file is your master record. Now, your program completely switches gears and becomes a reader. It's got to open that very same file, go through it line by line, and here's a key detail. It has to skip that header row you wrote. For every other line, it's going to parse the data and use it to rebuild a student object inside a new array. And to finish the round trip, you do a batch update. You're going to loop through your new array of students, add just a tiny 0.01 to each GPA, making sure you don't go over 4.0, and then you rewrite the entire studentinfo.txt file from scratch with all this new updated data. And these 2 steps, they're absolute heavyweights when it comes to points. Just reading the file back incorrectly, that's 50 points. Doing the update and rewrite process, that's another 45. That's 95 points combined. Nearly a third of your entire grade is sitting right here in this round trip. All right, let's talk about what happens when things go wrong, because they will. A user might type hello for a GPA, or maybe a file you're trying to read doesn't exist. A good program doesn't just crash and burn, it handles these things gracefully. That's where you build a safety net with try/catch.
So at its core, what is exception handling? Really, it's just your program's plan B. It's how you try a piece of code that you know might fail, and then catch the specific error if it does. This lets you respond to the problem without the whole application coming to a grinding halt. And the rubric couldn't be any clearer about this. It spells it right out for you. You have to use try/catch for both your user input and your file stuff. You have to give clear error messages. And most importantly, the program has to keep on running. No crashing. Period. And please, don't just glance over this. A full 30 points are tied up in getting this right. Why? Because in the real world, users make mistakes all the time, and files go missing. Building software that doesn't break is a fundamental skill, and that's really what's being tested here. Okay, we're in the home stretch. You've built the program, you've tested the data flow, you've put in your safety nets. Now it's just time for that final polish to make sure your submission is absolutely perfect. Let's make sure we secure every single point. Listen, your README file is not just some throwaway text file. It's a required part of the project. It needs to be a short and sweet technical summary. You'll need to say exactly where you put your try-catch blocks, name the specific streams you used, and point out how your array and toString method fit into the puzzle. And before you even think about hitting that submit button, run through this final pre-flight check. You need your 2 Java files, the final version of the text file, a screenshot that shows the whole process running, and your short README. Make sure everything is there.
And that's it. That is how you deconstruct this assignment into a series of clear, totally achievable steps. At its heart, this whole project is about mastering the flow of data, from a user to an object to a file and all the way back again. This is a skill you're going to use everywhere. Which leaves us with one final thought. Now that you know how to do this, what will you build next?